As we do this video, it'll be really helpful if you have your polyatomic ion list out in front of you. Before we cover using polyatomic ions, we should probably define them. You see, poly means many. Atomic refers to atoms. And ions means there's a charge. So these are many atoms glued together. Interestingly enough, they are covalently bonded. But they end up with a charge. So here I have nitrogen with 4 hydrogens all covalently bonded. However, it ends up with a +1 charge. Same goes for nitrate. Nitrate is 1 nitrogen atom covalently bonded with 3 oxygen atoms. And when it does that, it ends up with a charge of -1. Sulfate, again, 1 sulfate, 4 oxygens, and when that happens, when they covalently bond like that, they end up with an overall charge of -2. Example, phosphate. Phosphate is 1 phosphorus atom bonded to 4 oxygen atoms, covalently bonded. But when they bond like this, they end up with a charge of -3. To name a formula, using a polyatomic, there's only 2 polyatomics that are cations. Remember, cations have what charge? Positive. And there's only 2 on your list for me, and that is hydronium and ammonium. These are your only polyatomic cations. Everybody else is an anion. So it's very easy. You simply name the cation, which in this case is NH4. And the name of NH4 is ammonium. Then you name the anion, changing the ending to "ide." So in this case, we have fluorine, which becomes fluoride, and we're done. The rest of your polyatomics are going to be anions. And anions, in this case, remember, have negative charges. So the rules are very similar. First, we're going to name the cation. In this case, our cation is zinc. And you have to ask yourself, is zinc a type 1 or type 2 cation? Well, in this case, it's a type 1. And type 1, if you recall, type 1 cations, we don't need to know or put the charge in the name because it has a set charge. So now all you have to do is name the polyatomic. You don't have to change its ending at all. Simply name it. Sulfate, and you are done. Let's do another one because that one was kind of fun. So first off, you have to name the cation. So the cation in this case is copper. Now, you have to ask yourself, is it a type 1 or type 2 cation? Well, this is definitely a type 2. So if you recall, type 2 means find the charge. No, okay. I cut it in half. The cation versus the anion. The charge on the hydroxide, always -1. -1 times 3 is -3. So this half of the molecule has to be +3. So what number times +3? Oh yeah, you're already there, aren't you? It's +3. So it's copper 3. Now all you have to do is name the polyatomic. There's nothing to change. You just spit it out there. So that polyatomic is hydroxide. We're done with this. We're going to go the other direction and write the formula from the name. So first off, you need to write the ions. And this is so much easier if you know your polyatomics. Trust me on this. Now that you've done that, You need to add coefficients so the charges add to 0. So, using the least common multiple between 2 and 1, we get 2. 2 is our least common multiple. So we can put a 1 there or skip the 1. We don't have to write 1s. It's not necessary. Put a 2 there. Now we're going to add the chemistry symbols. Just because that's part of speaking chemistry. Now, write the formula using the coefficients for subscripts. How's that look? Does that look good to you? Be careful, because if you write it like that, you are not showing me 2 hydroxides. You're showing me 2 hydrogens, and that's a problem. Can't do that. Nope, can't do it. You need to use parentheses. So make yourself a note. Parentheses are used only when you have more. Yeah, write it down. More than one polyatomic. Now, here's the thing that gets me every time is sometimes students want to use parentheses on single atoms. You know, they're like, hey, we're using parentheses now. No, be careful. You're going to underline that, careful. You're going to use parentheses only when you have more than one polyatomic ion. That's it. It's the only time you're going to use parentheses. So much fun. We're going to try another one. Chromium 4 phosphate. Now remember, those Roman numerals are never, ever, 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 ever the subscripts. What are they? Yes, those Roman numerals represent the charge on the cation. Okay, good. So you got that. Here we go. Write the ions. Chromium with a 4+ charge, phosphate with a 3- charge. This is so much easier if you know your polyatomic ions, just to let you know. It's easier if you know. Now you're going to add coefficients so the charges add up to 0 using the least common multiple. And the least common multiple between 4 and 3 is 12. So what number times 4 gives us 12? 3. What number times -3 gives us -12? 4. Oh, that one wasn't too painful. Now we're going to add in the chemistry symbols. Now you need to write the formula using those coefficients for subscripts. Like that, right? And you got to be careful. We have more than one polyatomic ion, so that means we're going to need parentheses. Because without them, it looks like I have 44 oxygens and 1 phosphorus, and that's not cool. So we do not want to do that. What we want to do instead is use parentheses. That's a much better formula. This now shows 3 chromium ions and 4 phosphorus ions. Next, we're going to do acid nomenclature.